Hi again, class. We are going to talk about the number data types and expressions. So we talk about we used two different number types so far. Is the int and double. You can see it in this table. There are actually other data types, number types that we didn't use. For example, float and double are kind of similar because and long double as well, because they all represent numbers with decimal points. It's just how many data is in each of those types. So you can see that the floats use only 4 bytes of memory, and double use 8, and long double use 10, because floats can hold a smaller number compared to double and compared to long double. You can see the size range. The same for short, int, and long. So right now, because your programs are so small, so usually it doesn't really matter which type you use, as long as it's either whole numbers or with decimal points. But later on in your career, you should pay attention to how much memory you are using. So what is the relationship of memory and variables? So when you calculate, do any sort of calculation with variables, or using variables for any operations, the variables will be held in the memory so that it can be used to be calculated. It's just like when we are doing math in our head. If we want to add 25 to 12, we have to hold the number 25 and the number 12 in our head so that we can add them together. And it's the same for computers. So computers have to hold the value of those variables in the working memory so that it can do the calculation. If you want to read more, it's in section 1.1 of our textbook. I want to talk to you about how memory is allocated for different variables. So you can imagine like it's a sequence of variables, one next to each other, if you would like to, which is not exactly the case, but that imagination is good enough for now. We want to think about memory because when we allocate a memory for a variable, we want to think about, just the location is allocated, but the value inside, if we haven't done the assignment, actually what you would get for the value of that particular variable depend on what was already in the memory previously. So want to talk about this also because we have this question in the quiz. Int x equals to x plus 30. So what's the value of x after this statement? So because x in the first statement, when it's declared, no assignment of value to it was done. And so the value of it at this point really depends on what was there in the memory location. And so I would consider it garbage or unknown. And so when you don't know this, then no matter what calculation you do, what comes out is like you don't know what is going to come out. So the right answer is actually garbage, or better probably call it unknown. So it's always a good idea to initiate all your variables to a certain value before you start, especially for beginner programmer like yourself right now. Next, we will talk about the math operators that can be done for the integer type. I think you've seen some before, like the multiply. You can do division, but remember that for division of integers, it would not come out to become 1.5. It will actually only become 1. So for example, 3 divided by 2 is equals to 1. 5 divided by 2 is equal to 2 and not 2.5. So you have only the whole number that from the division, but not the remainder. So if you want to get the remainder, you can use the percentage sign. For addition, plus, and subtraction, minus, I think is pretty obvious to you. I would recommend that try this this out and see what happens on the cpp.sh. For doubles, the calculations are the operators are mostly the same, except that we don't have the remainder one. Also, actually, I want to get your attention about the order of precedence as well. So what it means is that if you have a train of like expression, it will first calculate the multiply before it does the division, for example, and before it does the addition. The same is for int as well. You can see from the last table. So I'm showing this to you, which is from Appendix 2. You can see that multiply and division and the remainder is obviously I spelled it wrong. So the percentage, they are in the order from top to bottom. So you can see from this table. And you can see that actually the input-output operator also are listed here. So examine it a little bit so that you understand it. But obviously, if you want to make sure that your program runs as expected, use parentheses. I think it's really the best way to prevent any unexpected results. So next, we'll talk about the assignment operators. It's basically like a shortened form to express assignment back to its own value. So basically, if we want to assign x times y back to the value of x, we can short form it as x times equal y. The same for all other operators. For example, x plus equal y means just x equals to x plus y, basically assigning the value of x plus y back to x. And then there's this other kind of operators, which is called the increment and decrement operators. The value of x will be increment by 1 when you see this plus plus. So when x starts with equals to 3, it will become 4. If minus is after x, then it will be decrement by 1. So when we start from 3, it will become 2. But you can see that you can postfix it and prefix it. So you can have the plus plus before the x and plus plus after the x. So what's the difference? We are going to show you. So let's just run this program so that, well, let's look at the code first. So we start with x equals to 0. And then if we do an x plus plus, if we print it out, the x will not be increment until after this statement is executed. So when we print x at this time, it will still be 0, but then afterwards it will become 1. However, in the case of plus plus come before x, the increment will be done before this statement is finished. So in here, the value of x will be 1 actually, and then afterwards it's still 1. So like I said, this is incremented after this statement is finished. So the before is 0, the after is 1, and then this is executed. The operation is executed before, and that's why it's it's the value of x is 1 already in this line number 14, and it'll be the same after. And like I said, you can always just click on this link in your PDF, and then you can play with it. So it's the end of this session. We will talk about the simple flow of control next.